Unit testing is a fundamental practice in software development. It serves as the first line of defense against bugs and errors. It involves testing individual units or components of your code in isolation. These units can be functions, methods, or classes. By doing so, you can verify that each part functions correctly. This helps in identifying issues at the earliest stage possible. This practice contributes significantly to the overall quality and maintainability of your software. Imagine building a house. You wouldn't wait until the entire structure is complete before checking if the walls are straight or the plumbing works. You'd inspect each part as it's built. Similarly, unit testing ensures that each brick of your software is sound before assembling the whole system. This proactive approach prevents larger issues down the line. Unit tests act as a safety net for your code. They catch errors early, making it easier to fix them. They give you confidence that changes you make don't introduce unexpected bugs. This is crucial for maintaining code integrity. This is especially important in large projects where multiple developers work on different parts of the code base simultaneously. Coordination and consistency are key. By catching errors early in the development cycle, unit testing saves you time and effort in the long run. It streamlines the debugging process. It's much easier and cheaper to fix a bug found during unit testing than one discovered in later stages of development, or worse, after the software is released. This proactive approach ensures a smoother development process and a more reliable final product. Effective unit tests share common characteristics. They are fast, isolated, and focused. These traits ensure that the tests are both efficient and reliable. Speed is crucial because developers should be able to run unit tests frequently, ideally after every small code change. This allows for quick feedback and rapid iteration. Each test should be independent of others. Independence is key to maintaining the integrity of the testing process. This means that the success or failure of one test should not influence the outcome of another. It ensures that each test result is accurate and trustworthy. This isolation ensures that tests are reliable and that failures point to specific issues in the code. When a test fails, it should be clear what part of the code needs attention. A unit test should focus on testing a single, well-defined piece of functionality. This precision helps in pinpointing problems. Avoid testing multiple things in a single test. Combining tests can lead to confusion and make debugging harder. This focused approach makes it easier to understand what's broken when a test fails. Clear, concise tests lead to quicker fixes. Think of unit tests as small, targeted experiments. Each test should have a clear purpose and expected outcome. Each experiment should test a specific hypothesis about how your code should behave. This scientific approach to testing ensures robust and reliable code. Often, the unit you're testing interacts with other parts of your system, like databases, file systems, or network services. These interactions are essential for the functionality of your application, but can complicate the testing process. Directly accessing these dependencies in your unit tests can make them slow and brittle. This can lead to tests that are difficult to maintain and prone to failure due to factors outside the unit's control. This is where mocking comes into play. Mocking allows you to simulate the behavior of complex dependencies, making your tests more reliable and easier to manage. Mocking frameworks like Mock allow you to create fake versions of these dependencies. These fake versions can be controlled and manipulated to suit the needs of your tests. Mocks mimic the behavior of the real dependencies but give you fine-grained control over how they respond in your tests. This control is crucial for testing edge cases and error conditions. For example, if your code interacts with a database, you wouldn't want your unit tests to actually connect to the database. This could introduce variability and slow down your tests. Instead, you'd use a mocking framework to create a mock database object. This mock object can be programmed to return specific data or simulate various database conditions. You can then configure this mock object to return specific data or throw exceptions, simulating various scenarios without relying on a real database connection. This makes your tests faster and more predictable. By isolating your unit under test with mocks, you ensure that your tests are focused solely on the logic of that unit and not influenced by external factors. This leads to more robust and maintainable tests, ultimately improving the quality of your software. Having clear and consistent naming conventions for your test files and methods is crucial for maintaining a readable and understandable test suite. A common convention is to name the test class after the class being tested, appended with tests. For example, if you're testing a class named User Controller, your test class might be named User Controller Tests. Similarly, test method names should clearly describe the specific scenario being tested. A descriptive name like should create user when valid data is provid-ed is much more helpful than a generic name like test1. These conventions might seem trivial, but they significantly improve the maintainability of your tests. When a test fails, a well-chosen name can quickly tell you what functionality is broken and where to start looking for the issue. Pause 3S. In this chapter, we will explore how to unit test exceptions and measure code coverage. Unit testing exceptions involves ensuring that your code correctly handles error conditions. Code coverage, on the other hand, is a measure of how much of your code is executed during testing. By the end of this chapter, you'll understand how to write tests that cover both normal and exceptional cases, and how to use code coverage tools to ensure your tests are comprehensive. Let's start with unit testing exceptions. When writing unit tests, it's crucial to ensure that your code handles error conditions gracefully. This means writing tests that trigger exceptions and verifying that the appropriate error handling logic is executed. For example, if a method is supposed to throw an illegal argument exception when provided with invalid input, your test should verify that this exception is indeed thrown. Next, we'll discuss measuring code coverage. Code coverage is a metric that indicates how much of your code is executed during testing. There are various tools available that can help you measure code coverage, such as Jacoco for Java projects or coverage.py for Python projects. These tools generate reports that highlight which parts of your codebase are covered by tests and which parts are not. By analyzing these reports, you can identify areas of your code that need additional tests to ensure comprehensive coverage. By combining unit tests that cover both normal and exceptional cases with code coverage tools, you can build a robust and reliable test suite. This will not only help you catch bugs early, but also give you confidence that your code behaves as expected in different scenarios. Stay tuned as we dive deeper into these concepts and provide practical examples to help you master unit testing exceptions and measuring code coverage. In this chapter, we will explore the possibility of generating a code coverage report in Visual Studio. Code coverage is a measure used to describe the degree to which the source code of a program is tested by a particular test suite. Visual Studio provides built-in tools to generate and analyze code coverage reports, which can help developers identify untested parts of their codebase and improve the overall quality of their software. First, let's walk through the steps to enable code coverage in Visual Studio. Navigate to the Test Explorer window and ensure that your test project is selected. Then, click on the Analyze Code Coverage option from the Test menu. This will trigger the code coverage analysis for your test suite. Once the tests have run, Visual Studio will generate a detailed code coverage report. This report highlights the lines of code that were executed during testing and those that were not. Lines of code that are covered by tests will be marked in green, while uncovered lines will be marked in red. This visual representation makes it easy to identify areas of your code that need additional tests. Next, we will discuss how to interpret these results to ensure comprehensive testing. Pay close attention to the parts of your code that have low or no coverage. These are potential weak points that could harbor bugs or unhandled edge cases. By writing additional tests to cover these areas, you can improve the overall robustness of your application. Finally, remember that code coverage is just one metric of code quality. High code coverage does not necessarily mean your tests are effective. Ensure that your tests are meaningful and validate the correct behavior of your code, not just aim to increase coverage percentage. By leveraging Visual Studio's built-in tools for code coverage, you can gain valuable insights into your test suite's effectiveness and ensure that your application is thoroughly tested. This will help you catch issues early, improve code quality, and maintain a reliable software product. Stay tuned as we continue to explore more advanced topics in unit testing and code quality assurance.